Welcome to RHCSA.GURU. In this lab, we'll explore how to manage containers using Podman. We'll walk through some of the fundamental Podman commands. Docker is commonly used to create and manage containers. In Red Hat, it's been replaced by Podman, a daemonless engine for running OCI containers on Linux. We'll install Podman by running the following command. Type dnf install ypodman in terminal and hit enter. This command will install Podman without any prompts. To check which version of Podman is installed, we will run the following command. Type podman -- version in terminal and press enter. It displays Podman version. We can access Podman's help menu using either the man command or by running podman -- help in terminal and press enter. This command displays Podman's command option. Now, we will use the info command to get detailed information about the Podman engine. Type podman info in terminal and hit enter. It displays info, including its version storage driver registries and other settings. Now use the search command in Podman to look for images in the registry. We will get the list of images in registry. Type Podman search HTTPD in terminal and hit enter. It lists available HTTPD images from registries. Now, before pulling any image, we will check which images are already available on the local system by using the following command. Type Podman images and press enter. Displays all local container images. Now, download the image by running the following command. We can pick any image from the registry list we found earlier. Type the command in terminal and enter to run the command. It downloads the HTTPD image from the remote registry to your local system. Now check the local image list again. We should see the HTTPD image included in the list Podman images. Displays updated local images with HTTPD images. Before we run the HTTPD container, let's list all currently running containers using podman ps command. Displayed all currently running containers. To start the downloaded image as a container, we'll use the podman run command. The D flag runs it in detached mode, T provides a TTY shell, and P maps the container's port to the host. Type the command in terminal and hit enter to run the command. Task completed. Now, let's check the list of running containers. We should see the HTTPD container running. Type podman ps command in terminal and enter to run. Displays the running containers. We see the HTTPD container active. Now, let's run another container using the same image, but on a different port. This allows both containers to run without conflict. Type the command in terminal and press enter. This command will start a second HTTPD container named HTTPD2 using port 8082. Task completed. Next, we'll list all running containers again using podman ps command. Clear the terminal and type the command. We now see both the original HTTPD container and the new HTTPD2 container running. To view the logs of the most recently started container, we can use the following command. Type podman logs -l and hit Enter to view the logs. Now, to inspect the state and configuration details of a specific container, we'll use the Inspect command. Type Podman Inspect HTTPD2 command and Enter. It displays details of the HTTPD2 container. To stop a running container, we use the Stop command. Type Podman Stop HTTPD2 command in terminal and Enter. It will stop the container. Click on Check. Task completed. Let's list all containers, including the ones that have exited. For that, we use the A option with PS. Type Podman PS-A and hit Enter. We can now see the HTTPD2 container in the exited state. Now we will start a stop container by simply running a command. Type Podman Start HTTPD2 in terminal and hit Enter. It will start the stop container. Task completed. Now, let's create a container without starting it. We'll use the Create command along with the Name option to name the container. Type Podman Create. Name httpd_container docker.io/library/httpd in terminal. Task completed. Next, we'll list all containers to confirm that HTTPD container has been created. Type Podman PS-A in terminal and Enter. Result displayed that container is created. Let's start the container we just created. After starting, we can run Podman PS to verify its status. Type Podman Start HTTPD_container in terminal and press Enter. It will start the container. Task completed. To make the container start automatically after a system reboot, we need to create a systemd unit file for it. Use the following command to generate the file. Type Podman Generate Systemd. New Files. Name HTTPD_container in terminal and press Enter to generate a systemd service file for the HTTPD container. Now we will move the generated unit file to the correct directory so that systemd can access it. Type the command in terminal and hit Enter. Task completed. Let's view the contents of the unit file using cat command. Type cat/systemd/system/container_httpd_container.service in terminal and press Enter. Result displays the content of the service file. To avoid any SE Linux-related issues, we'll set the correct context for the unit file. Type chcon t systemd_unit_file_t/etc/systemd/system/container_httpd_container.service in terminal and press Enter. This command will set the correct SE Linux context so systemd can read the service file. Click on Check. Task completed. Now reload the systemd daemon so it recognizes the new service file. Type systemctl daemon reload command in terminal and hit Enter. To check the current status of the container as a systemd service, use the following command. Type systemctl status container http://d_container .service command in terminal and hit enter. The status is inactive. Now we will start the container using systemd with this command. Copy and paste the command in terminal and hit enter. Task completed. Again, check the status to ensure the container is running as a systemd service. Paste the command in terminal and enter. Confirms the container service is running. You've successfully completed the lab. Don't forget to mark this lab as completed.